All right, here we are in lesson 4.7. We are going to learn a new form of writing equations of the linear form. Here we go. This is called the point slope form. So, what we've learned in this chapter, we have standard form. And it just kind of depends. Like when we have the variables on both sides, so we have ax plus by is equal to c. So both or y and x are on the same side of the equation. That's called standard form. We have slope intercept form. And that's when we have solved for y. We call this function form. Slope intercept form is most familiar because we have solved for y. And then now we are introducing a form called point slope form. And what this is going to help us do is to be able to calculate the equation of a line, because we can take it from point slope form into slope intercept form pretty easily. And maybe we know a point, but one of them, notice how this blue line does not cross the y-axis. So if we don't immediately know the slope or the intercept, then we can use this information, calculate the slope, use this form of the equation to get it into slope intercept form, which is always going to be our goal when we're solving for y. Okay, let's see here. All right. So writing in point slope form, the equation. Now, sometimes we'll leave it in point slope form, so pay attention to the directions. Write in point slope form an equation. It goes through this point, which is not the y-intercept, right? It's just a point on the line, and it has this slope. So we get to plug in the values. This becomes x1, and this becomes y1. So we plug in y1, we plug in the slope, and we plug in x1. Then we can simplify. Right here, we have to simplify this double negative, and we have our final answer in point slope form. Okay, so let us do that. So we are going to write in point slope form an equation of a line that goes through this point. So remember, this is x1, this is y1. I'm going to put the point slope form up here. We will take y minus y1. Make that equal to the slope times the quantity x minus x1. And now we will just plug in. So we have kind of like y minus, and then we have a blank space, and then we have the slope, which is a blank space, and x minus, and another blank space. Kind of taking up a lot of room here. So let's go ahead and substitute in these three values. So we want to plug in the 2, we want to plug in the slope, and then we want to plug in the 1, which is the x1. So we can just write that more neatly. There are no double negatives. And here's our point slope form. Okay, I'm going to let you do number 2 and see if you can get that in point slope form for me. And I'll work on number 3. So for number 3, we want to put y minus, and then we're going to substitute in y1, make that equal to the slope times the quantity x minus, and then we're going to substitute in x1. So y1 is a negative 5. The slope is a negative 3/4, and x1 is a negative 8. Now we have a few things to simplify here and clean up. So we would change this to y plus 5 is equal to a negative 3/4 and x plus 8. And there's our point slope form. All right, here we go. Next, we're going to take it all the way to slope-intercept form. And so pay attention to the directions. Write in slope-intercept form an equation that goes through these 2 points. So first we have to calculate the slope using our slope formula. Then you can pick one of the points. And it won't matter which point you pick. And I'm going to illustrate that real quick. So they picked the 2, 4, right? What if I picked this one right here? I would say that that is, y, and then minus a -2 would be plus 2, equal to the slope of -2 times x minus 5. So what you're going to do then is just use the distributive property, okay? So we'll have y plus 2 is equal to a -2x plus 10, because I took the -2 and I multiplied it to each term inside. Then I will simplify and solve for y. So I get y is equal to -2x plus 8. And as you can see, using the other point, that's what we get as well. So remember these 2 points, this one right here and this one, fall on the same line, and there's only one linear equation for that line. All right, so we are going to be doing that and taking one of the points and then taking it all the way to slope-intercept form. So let's do that with this. So we want to first calculate slope. So y2 minus y1 over x2 um, minus x1. So we have this double negative here. So we'll have a -4 minus 1, which is a -5, and then 3 plus 2, +5. So our slope is a -1. So then when I substitute in the values, y, and I can call this x1, y1, because that's kind of what I did here, y, minus 1 is equal to our -1 times the quantity x minus this -2. Okay, so we want to simplify that. Y minus 1 is equal to -1 times x plus 2. Now we'll distribute. Y minus 1 is equal to -1x or -x and minus 2. Then we'll add 2 to both sides. So we'll get y is equal to -x plus 0, or we could just leave it as y is equal to -x. Okay? All right. I want you to do this one. So pause the video, try to work that out, make your work kind of line up to this using the point slope form of an equation. And then taking that and solving it all the way to slope intercept form, which is y is equal to mx plus b. Okay, I'm going to continue with number 6. So first step, solve for slope, right? Rise over run. So change in the y values and over the change in the x values. So 9 minus 6 over -2 minus the -8. So 9 minus 6 is 3. And then -2 plus 8 is going to be +6. So that is equal to 1/2. So our slope is 1/2. So I'm going to go with these values because they're both even, right? That's going to help me distribute my slope a little bit better. So y minus 6 is equal to a +1/2 times x minus the -8. So y minus 6 equals 1/2 x plus 8. Now I'm ready to distribute. Y minus 6 is equal to 1/2 of x, and then half of 8 is 4, and then I'll add 6. So I'll get the slope intercept form of 1/2 of x plus 10. All right. So remember, we're using this form, and it will help us write the linear equation between 2 points when one of those points is not the y-intercept.